Hi everyone! Today we're going to be talking about properties of congruence and segment proofs. Our objectives for today are that students will be able to write proofs involving segment addition and write proofs involving congruence. Let's get started. Alright, so last class we talked about, or the last video notes that you saw, we're talking about properties of equality, and we learned all about these properties of equality. Alright, so these properties can only be used when we're dealing with equal signs. So anytime we're using an equal sign, then it's properties of equality. So if we're doing algebraic proofs and it's an equal sign, we use properties of equality. The next properties that we're going to be learning about are properties of congruence, and those can be applied to statements that use congruence symbols. Alright, so the way I like to distinguish between something being equal or something being congruent, an example that I like to use is think of two tables. If a table is congruent to another table, that means they're the same. They're the same table. But if we're talking about the measure of the table or the length of the table, we say the length of the table is equal to the length of the other table, all right? So if something's congruent, that just means it's the same. But if their measures are equal, that's when we're talking about equal length, and that would be properties of equality when we're talking about their lengths, okay? And that's how segments are different. So if we're saying two segments are congruent, we're saying one segment is the same as the other segment. They're congruent. But if the measure or the length of a segment is equal to the length of another segment, that means equality. All right? So it's important to distinguish the difference between something being congruent or equal. Alright, so last class we talked about reflexive, symmetric, and transitive properties, but we talked about them in terms of equality. Now we're going to be talking about them in terms of congruence. That's why it's so important to write of equality or of congruence in this case. So reflexive property of congruence states for any segment AB, we can say that segment AB is congruent to segment AB. So the two segments are congruent to each other, or the segment is congruent to itself. Symmetric property of congruence states that if we say segment AB is congruent to segment CD, then we can also say that segment CD is congruent to segment AB. So we're switching them around, and because we're using that congruent symbol in between, not the equal symbol, all right, it is the symmetric property of congruence. And then last but not least, the transitive property of congruence states that if segment AB is congruent to segment CD, and segment CD is congruent to segment EF, then we can say that segment AB is congruent to segment EF. So we're saying both of these segments are congruent to segment CD, therefore they're congruent to each other. Transitive property of congruence. Alright, now we kind of want to give some obvious things names. So we're saying we're going to give something that seems obvious to, at least to me, hopefully to you too. We have to give it a formal name and call it the definition of congruence, all right? Because that's what we're going to use as our reason in our two-column proofs. So we're saying if segments are congruent, if, that shouldn't be congruence, segments are congruent if and only if they have the same measure. Okay, so if a segment is congruent to another segment, it means they have the same measure. We know this, but we have to write it formally and give it a name, and we call it the definition of congruence. So basically what this says, if segment AB is congruent to segment CD, then the measure of AB is equal to the measure of CD. And when we're talking about measures, we don't put the little line over it, okay? So if it doesn't have the little line over it, that means it's the measure of segment AB. And we say the measures are equal, the segments are congruent. Also, if the measures are equal, okay, so it can go the other way around. If we're saying the measure of AB is equal to the measure of CD, then segment AB is congruent to segment CD. So basically the definition of congruence allows us to go back and forth. It allows us to say that if the segments are congruent, then the measures are equal. If the measures are equal, then the segments are congruent. And our reason if we ever did this in a two-column proof would always be definition of congruence. All right, and then another obvious piece of information that we're giving a formal name, we're calling it the definition of a midpoint. If the midpoint of a segment divides the segment into two equal congruent parts, all right, then that is the definition of a midpoint. So for example, if M is the midpoint of AB, so if we have AB and M is the midpoint, then we can say that the measure of AM is equal to the measure of MB. And even though this seems like an obvious piece of information because we learned about the midpoint last chapter, all right, we have to give it a formal name, and its formal name would be definition of midpoint. All right, hopefully y'all remember the segment addition postulate from last chapter, all right, but the segment addition postulate states that if A, B, and C are collinear points and B is between A and C, then AB, the measure of AB, plus the measure of BC equals the measure of AC. So the part of the segment plus the other part of the segment equals the whole segment. All right, and we're reviewing this postulate because this can be a reason we use in our two-column proofs, all right? So add segment addition postulate to your list of reasons that we can use in two-column proofs. All right, so now we're going to get some practice identifying the different properties of equality, properties of congruence, different definitions and postulates, all right? So if you're given a statement, I want you to try to come up with the reason, and the reason's always going to be a property of equality, property of congruence, definition, postulate, theorem, so on, all right? So let's start with number 1. If the measure of PQ equals the measure of PQ, then segment PQ equals segment PQ. All right, so right off the bat, you would think, okay, this is reflexive property because PQ equals PQ, therefore segment PQ is congruent to segment PQ. All right, but this is not reflexive property. We have to be careful because what we're saying is that if the measures are equal, then the segments are congruent. This would be definition of congruence because we're going from measures are equal to segments congruent. All right, so be careful with that one. So this would be definition of congruence. And this is a way you can abbreviate definition of congruence that I will accept. All right, so def dot of, and then instead of saying congruence, you can write the congruent symbol. All right, number 2. If K is between J and L, then JK plus KL equals JL. So what this is saying is if we have a line that looks like this, we've got J and L, and K is between, then JK plus KL equals JL. So the part of the segment plus the part of the segment equals the whole segment. This is the segment addition postulate, okay? Hopefully you guys know this one by now. Segment addition postulate. Then number 3. Segment EF is congruent to segment EF. So this one would be the reflexive property, and because we've got a congruent symbol in here, this would be reflexive property of congruence, all right? So segment EF is congruent to segment EF. We're saying they have the same value. So this would be reflexive property of, and we have to say of congruence because it's not of equality. So that symbol you put after the word of really, really matters. Then number 4, if RS is equal to TU, so the measures of RS is equal to the measure of segment TU, then RS plus XY equals TU plus XY. So what changed from this to this? What we're doing is we're adding the measure of xy to both sides of the equation. So if we're adding the same value to both sides of the equation, this would be the addition property. And because, all right, so for that one, we can just say addition property. So let's write that down. Addition property oh, and don't forget the of equality, all right, because it's on our properties of equality sign, all right? It's not congruence because we're not using a congruent symbol in here. We've got an equal sign in there, so that's a property of equality. Then, number 5, if AB equals DE, then DE equals AB. All right, so we're switching them around. And because there's an, okay, so first of all, if we're switching them around, that would be symmetric property. And then because there's an equal sign in there, not a congruent symbol, this would be symmetric property of equality. All right, so we would write symmetric property of equality. And another key way we can recognize that this is of equality is we don't have the little line over our AB. All right, when we have the little line over AB, we're talking about the segment itself. No line means we're talking about the measures of AB and the measure of DE. And when we're talking about the measure, we're talking about equality. Number 6, if y is the midpoint of xe, then xy equals yz. All right, so automatically we see the word midpoint in there. The only property of equality, congruence, definition, or postulate in our property bank that deals with midpoint is definition of midpoint, all right? And if we know y is the midpoint of xe, then cuts it in half and the two measures are equal. So our reason or our property, definition, postulate to describe this would be definition of midpoint, all right? So that would be our answer. Alright, so I want you guys to try numbers 7 through 12. Try to identify the property of equality, property of congruence, definition, or postulate that goes with each of these statements. When you come back, I'll have the answer written on your screen and we'll go through it together. So go ahead and try these ones now. Pause your video. Alright, so here's the answers to 7 through 8. If you got them all right, you can go ahead and fast forward through the video and skip this and move on. If you didn't get all of them right, I would listen up as I go through the explanation for each one. Alright, so number 7, we've got if FG is congruent to HI, segment FG is congruent to segment HI, and segment HI is congruent to segment JK, then segment FG is congruent to segment JK. So if A is congruent to B and B is congruent to C, then A is congruent to C. They're both congruent to HI, therefore they're congruent to each other. This would be the transitive property, and because we're dealing with congruence, we've got the congruent symbol in there. It's transitive property of congruence. All right, so it's important what comes after the word property. Number 8. If AB plus CD equals EF plus CD, then AB equals EF. So how did we go from this to this? What we did is we subtracted CD from both sides of the equation, and that's how we got AB equals EF. Therefore, this would be subtraction property, and because we're dealing with the measures of the segments and there's equal signs in there, it would be subtraction property of equality. Number 9, if PQ plus RS equals TV and RS equals WX, then PQ plus WX equals TV. So what we're doing is we're saying RS is equal to WX. So we can take WX and substitute it in for RX here. And that's how we get this equation. So this is the substitution property. All right. And substitution property would be a property of equality. So I should actually have of equality written here. All right. Then number 10, if LP equals PN, and LP and N are collinear, so they're all on the same line, then P is the midpoint of LN. This is the definition of a midpoint. So our reason is just definition of midpoint. Keyword there is midpoint. Kind of gives it to you, gives it away. Number 11, if segment UV is congruent to segment UV, then the measure of UV is equal to the measure of UV. So we're going from segments are congruent to their measures are equal. Anytime we go from congruent to equal or equal to congruent, our reason is definition of congruence. All right, and you can say definition of congruent symbol. I would accept that as an answer. All right, we like to use shorthand and write symbols. All right, it just has to be the correct symbols. And I have to be able to read it. Number 12, if CD plus DE equals CE, then CD equals CE minus DE. So that's kind of a tough one. We got to look at it. How did we go from this equation to this equation? What did we do to both sides of the equal sign over here to get this? What we did is we subtracted DE from this side and subtracted DE from this side. It'll cancel out over here, and then over here we'll be left with CE minus DE, and that's how we get this. So because we subtracted DE from both sides of the equal sign, and because we're dealing with an equal sign, this would be the subtraction property of equality. All right, so if you're understanding this, you're good to go. Keep going. Otherwise, raise your hand, call me over so I can help you. All right? So if not, let's move on. All right, so today we're going to be writing segment proofs. So last class we talked about algebraic proofs. Today we're doing segment proofs. So hopefully you have this handout still with you. All right, hopefully you can remember. We're going to quickly go through these steps again, give you a little refresher on all the things you need to do when you're trying to write a proof. Everything we tried to do for algebraic proofs, we're going to try to do the same thing with segment proofs. All right, our first step is to always copy all the given information, all right? Whatever you're given, copy it down as your first statement, and your first reason should be given. Then what you want to do is pause to get an understanding of what you know and what you're trying to prove. All right, so pause, stop, and think about what you know, what is your given information, what are you trying to prove. Make marks on the diagram, all right? That diagram is key to you, all right? It'll help you visualize the situation and come up with a plan of action. Once you've got that plan of action, write and work with the equations based on the given statements first, right? We always want to start with our given statements, all right? Work with those first. Sometimes you can convert those statements into equations using the definitions and postulates and properties that you know. Then we want to try to develop new equations from the diagram, all right? So once we've used all the given information, then we want to look at our diagram and come up with new equations or new statements from our diagram. Last but not least, we want to manipulate and combine all of our equations, always keeping your goal in mind, all right? If it's not going to help you prove what you're trying to prove or reach your goal, there's no point in writing it down as a statement, all right? Remember, you can always use transitive property or substitution to combine two lines or relate two lines together. These are the common steps that we're going to take that we use to solve algebraic proofs, that we're going to use to solve segment proofs today, and we'll get to angle proofs next time, but don't worry about angle proofs for now. All right, so you should have in front of you a list of reasons for proofs numbers 1 through 6, all right, the segment proof guide. So these are all reasons that complete each of the proofs 1 through 6. We're only going to do 1 through 3 together, or 1, 3, and 5 together, obviously, because we only do the odds. But if you ever wanted to go back and try 2, 4, and 6 on your own for extra practice, these are the reasons that you would use and kind of use them like a word bank to fill in those proofs. All right, so let's get started on proof number 1. All right, so our first proof, we are given that E is the midpoint of DF. All right, or I should say our first segment proof. E is the midpoint of DF. We've got our diagram. E is the midpoint of DF. We want to prove that 2 times the measure of DE is equal to DF. So, first thing we want to do is start by listing out our given information, that E is the midpoint of DF. And we know that the reason for this is it's given. Then, we want to think about what is our end goal. Our end goal is going to be that 2 times the measure of DE equals DF. So that's obviously going to be our last step. And then all the statements in between are, how did we get there? So, how did we get there? The next thing that we can say is that DE is equal to EF. So the measure of DE is equal to the measure of EF. And how do we know this? Why is that true? Why is the measure of DE equal to the measure of EF? If you said because it's the midpoint, that is right. Because E is the midpoint, we know that the measure of DE is equal to the measure of EF. So our reason for this would be definition of a midpoint. That is our reason for statement number 2. So anytime we make a statement, we have to give a reason that justifies it or supports it, okay? So if we say that DE, the measure of DE is equal to the measure of EF, we have to support that with because that's the definition of a midpoint. Next thing we can say is we can go from DE equals EF to DE plus DE equals DE plus EF. Now, what changed from statement 2 to statement 3? What we did was we added the measure of DE to both sides of the equation. All right, so we added DE to DE equals EF. So therefore, this would be the addition property of equality. All right, because we're adding the same thing to both sides. So addition property of equality. Then what we can do is, how do we go from step 3 to 4? How do we go from statement 3 to statement 4? What we did here is we took DE plus DE and simplified this to 2 times DE. So therefore, our reason for this would just be that we simplified. Next, we want to look, how do we go from statement 4 to statement 5? What did we do? So if we look at it, we ask ourselves, what did we do? We can't really relate statement 4 to 5, so that's not going to give us our reason 5. But what we can do is look at statement 5, and we know that DE plus EF equals DF. That relates to our diagram. So if we're looking at our diagram, that's how we came up with statement number 5. So we are finished with manipulating the equations we had, and now we'd make an equation based off of our diagram. So DE plus EF equals DF. And this is true because part of the segment plus part of the segment equals the whole segment. Therefore, the reason for this is segment addition postulate. So we write that down, segment addition postulate. Next, we want to look at all of our previous statements and ask ourselves, how did we get to this statement right here? How did we get 2 times DE equals DF? So, how did we get there? Well, we can see that we can look at statements 4 and 5 and see how they relate to each other. So 2 times DE equals DE plus EF. DE plus EF equals DF. So if A equals B, B equals C, then A equals C. So both of these equal DE plus EF, DE plus EF. So therefore, we can say 2 times DE equals DF because of the transitive property. All right, and because we're dealing with equal signs, it's the transitive property of equality. All right, and you're done filling in your reasons for your first segment proof. All right, number 3, we're given that segment PQ is congruent to segment TQ and segment UQ is congruent to QS. So first thing we want to do is kind of mark up our diagram so we can see this. So we know PQ is congruent to TQ and UQ is congruent to QS. All right, so we marked up our diagram so we can see which segments are congruent to each other. All right, and we also take that given information and write it down as our first statement. So our first statement is our given information, and the reason for our first statement is given. All right, about 99% of the time, your first statement and reason will always be the given information and given. Then we know that we're trying to prove that PS is congruent to TU. That is our end goal, so that's always going to be our last statement. Now, we've got all these statements in between, and we want to ask ourselves, how did we get them? So, starting with statement number 2, we've got PQ equals TQ and UQ equals QS. So what changed from statement 1 to statement 2? We went from saying the segments are congruent to their measures are equal. So anytime we go from congruent to equal or equal to congruent, that is always the definition of congruence. All right, so definition of congruence. Then statement number 3. Statement number 3, we look at it. It doesn't really utilize this up here. All right, we're not really saying anything about statements 1 or 2 and how they relate to 3. So the next thing we want to do is look at our diagram and see if it relates to our diagram in any way. So PQ plus QS equals PS. PQ plus QS equals PS. And TQ plus QU equals TU. Both of these statements are saying the part of the segment plus the part of the segment equals the whole segment. Therefore, the reason for both of these statements would be segment addition postulate. So that is our reason number 3, segment addition postulate. Then let's look at statement number 4. So statement number 4 is saying TQ plus QS equals the measure of PS. So how did we get that? So TQ plus QS equals PS. We can see that it sort of relates to statement number 3 because it kind of looks like this one right here, right? Except PQ and TQ changed. We also know that PQ is equal to TQ. So what changed from 3 to 4 was that we substituted in TQ for PQ. We took TQ, plugged it in for PQ, and that's how we got statement number 4. So our reason for that would be substitution. All right, so our reason for statement number 4 is substitution. All right, because we look back at number 2 and know that PQ is equal to TQ. Then, how do we get statement number 5? Well, statement number 5 kind of looks like the second half of statement number 3, except QU, we substituted in QS. And we know from statement number 2 that QU is equal to QS. Therefore, we just substituted QS in for QU. So our reason for statement number 5 would also be substitution. Then let's look at number 6, so statement 6. How did we get statement 6? So if we look back at statements 4 and 5, we see that TQ plus QS equals PS, and TQ plus QS also equals TU. So both of these are equal to TQ plus QS. Therefore, if they both equal the same thing, then we can say that these are equal to each other. So if A equals B and B equals C, then A equals C. So PS plus TU would be transitive property of equality, and it would be of equality because we're dealing with an equal sign. There's an equal sign in there. So we say transitive property of equality. And then last but not least, how do we go from statement 6 to 7? They look identical, except one is saying the measures are equal, this one is saying the segments are congruent. So anytime we're going from equal to congruent or congruent to equal, always the definition of congruence. All right, so statement number 7 would be definition of congruence. And you're done. All right, so I want you guys to try number 5 on your own. Use your little guide with a word bank to help you fill in the reasons that should go in reasons 1 through 6. All right, so try to do this one on your own. When you come back, I'll have the answers written on your screen and we'll go through it together. So go ahead and pause your video now. All right, so here are your answers to number 5. If you got it right, you can go ahead and fast forward and move on to the next one. If you didn't get it right, I would stay tuned and keep listening for an explanation on how we got each of these. All right? So number 1, first thing we want to do is state our given information. So we look at what's given, copy it down as statement number 1. Our reason is always given. Then look at statement number 2. How do we go from 1 to 2? They're identical except that statement 1 is saying the segments are congruent. Statement number 2 is saying that the measures of the segments are equal. So anytime we go from congruent to equal or equal to congruent, this is definition of congruence. Then statement number 3 doesn't really relate to 1 or 2. So what we want to do is look at our diagram, and we can see that it says xy plus yz equals xz, tu plus uv equals tv. Therefore, we're saying part of the segment plus part of the segment equals whole segment, and the same thing for TV. So this is segment addition postulate. Then we want to look at statement number 4, and we see that it's kind of similar to statement number 3 except for a couple things. So what changed from 3 to 4? If we're looking at these first two equations, we see that the only thing that changed from here to here is xy and uv. So we substituted in uv for xy, and we can do that because we already proved in statement number 2 that xy is equal to uv. So we substituted it in. Same thing for these second two equations. The only thing that changed from here to here is that we substituted in yz for tu, because in statement number 2 we previously proved it. So we can't substitute those in until we prove it in a previous statement. And because we proved it in step 2, we can take that and substitute it into step 3, and that's how we get step 4. So the reason for step 4 would be substitution. Then for step number 5, what we want to ask ourselves is, how did we get step 5? What did we use in our previous statements to give us step 5? And if we look at these, we can see we want to look for xz, and where does xz appear? So xz appears here, and tv appears here. Where are they similar? Okay, so if we're looking at this, we see that uv plus yz equals xz, and uv plus yz, they're just kind of switched around, but it's still the same thing because it's adding, also equals tv. So this and this are the same. So if xz and tv equal the same thing, then we can say that they equal each other. And this is the transitive property. If A equals B, B equals C, then A equals C. So how we got statement number 5 was we're saying xz equals this and tv equals this, and they equal the same thing. Therefore, this is the transitive property of equality. And last but not least, we're going from measures are equal to segments are congruent. Therefore, that is always the definition of congruence. All right, if you have any questions about this, please call me over so I can help you. Otherwise, let's move on. Alright, so I know the video notes are a little bit long today, but that's only because I really want to make sure to go through a lot of examples of segment proofs with you, because proofs can be challenging. Alright, so I want to be sure to go through a lot of different examples with you so you really understand proofs. Alright, so number 7. We're given that E is the midpoint of AC and that DE equals EC. So, now we're given some statements and some reasons, and we have to fill in some of the statements and some of the reasons. So before I gave you all the statements and you gave me the reasons, now it's all mixed up. So E is the midpoint and DE is equal to EC. So what we need to do is first state our given information. So step number 1, E is the midpoint of AC. That is given information, so we know that our reason for number 1 is given. Also, we know we have one other piece of given information, and that's that DE is equal to EC. And we have another reason over here that says given. So to match that given, what we want to do in statement number 3 is write down our other piece of given information. So measure of DE equals measure of EC is going to go there. All right, because that is another piece of given information. Now let's mark up our diagram with our given information so that we're able to analyze our diagram and know what we're seeing. So DE is this segment is congruent to EC, and we're going to use that. We marked up our diagram so it'll be easy to see in our diagram. All right, now statement number 2, we know our reason for statement number 2 is dealing with the definition of midpoint. So what is the definition of a midpoint? Definition of a midpoint says that if E is the midpoint of AC, that means that it cuts AC in half. Therefore, if by the definition of a midpoint, we know that AE is equal to EC. So that would be the statement we could write based off of the definition of a midpoint. So that's what we want to write in statement number 2, that AE is equal to EC. All right? And now we can mark that on our diagram as well. We know that AE is equal to EC. Now, what do we see here? We see that AE is equal to DE, but how did we get that? All right, so we know that we marked EC twice. We said that EC is congruent to DE and that EC is congruent to AE. It has both a single red line and a double green line. So if we're looking back at our previous information, what we're doing here is we're saying that both of these equal EC, right? So if they both equal the same thing, then we can say that these are equal to each other, right? If A equals B, B equals C, then A equals C. If they're both equal to the same thing, they equal each other. And this would be the transitive property. So our reason for statement number 4 is transitive property. And this would be transitive property of equality because we're dealing with the equal sign here. All right, and then we know that definition of congruence is we're saying that anytime we go from equals to congruent, so the measures are equal, the segments are congruent. So if we know our reason for number 6 or for number 5 is definition of congruence, all we want to do is go from 4 is equal to 5 is congruent. So we would want to rewrite number 4 as saying segment AE is congruent to segment DE. Definition of congruence, because we went from equals to congruent. And then last but not least, how did we go from 5 to 6? What changed? Well, the only thing that changed is we switched them around. Which property deals with switching them around? If you said the symmetric property, you're right. So we just switched them around, so that would be symmetric property. And because it has a congruent sign in it, we're dealing with congruence, we would say symmetric property of congruence. And we're done. Alright, so this is the last example we're going to do today, and I want you guys to try to do this one on your own. So I want you to practice one where you're giving statements and reasons. You're filling in the blanks for both statements and reasons. So try to do number 9 on your own. When you come back, I'll have the answer written on your screen, and we will go through it together. Alright, there's no word bank for this one, so you've got to come up with all of them on your own. Alright, so go ahead and pause your video and try it now. All right, so you should have gotten given, N is the midpoint of MO, definition of midpoint, LM equals NO, and LM is congruent to NO. If you got all those, you're done for the day. You can look to the board to see what to do next. All right, if you didn't get all those, listen up as I walk through it and show you how we got those answers. All right, so number 1, first thing we want to do is take our given information and make sure it's in our chart. So M is the midpoint of LN. That is given. Also, we know we've got another reason here that says given, so we want to plug in our second given reason, okay, or our second given statement. So N is the midpoint of MO. That is our other given statement. Now, based on this information here that M is the midpoint of LN, if we know M is the midpoint of LN, we can say that LM is equal to MN, okay? So I didn't mark that on the diagram, actually. Let's mark that up. Okay, so LM is equal to MN. Those two are equal or congruent, right? Because definition of congruence, if two are equal, then they're congruent. Then we can say that N is the midpoint. That was another piece of given information of MO. So therefore, MN is equal to NO. If N is the midpoint of MO, MN is equal to NO, and this is by definition of midpoint, all right? That is what it means to be a midpoint. Then we use our information, our statements that we've made, and we can identify that both of them equal MN. LM equals MN, and NO equals MN. If they equal the same thing, Therefore, they're equal to each other. If A equals B, B equals C, then A equals C. This is the transitive property of equality. So that's why we can say that LM equals NO. And then last but not least, we're trying to prove that the segments are congruent, not that their measures are equal. So in order to go from measures are equal to segments are congruent, this would be definition of congruence. All right, so if you have any questions on segment proofs, be sure to ask today, all right? If not, look to the board to see what to do next, and I hope that you have a great day.